Okay, so let's go look at one more problem from section 8.3. And this is problem 5 in the homework. And it says the pass completion percentages of 10 college football quarterbacks for their freshman and sophomore seasons are shown in the table below. So at a significance level of 0.10, is there enough evidence to support the claim that the pass completion percentages have changed? Okay, and we're going to complete parts A through E below. Okay, so in part A, we're going to identify the claim and then state the null and alternative hypotheses. Okay, so the first part of the question asks, what is the claim? Okay, so read the answer choices carefully and then select the best one. So let's like answer choice D is the best answer choice. Okay, and on the next part, we're going to select the correct null and alternative hypotheses. Okay, so it says let mu D be the hypothesized mean of the differences in the pass completion percentages, right? Freshman minus sophomore. Okay. And then it says that D bar, okay, is the sample mean of those differences. Okay, and this is our sample data, our paired sample data for 10 football players. Okay, so what are the null and alternative hypotheses? Okay, so the claim is that the pass completion percentages have changed. Okay, it doesn't say that the pass completion percentages for freshmen is less than that for sophomores, or for example, the pass completion percentages for sophomores is greater than that of freshmen. It just says that they have changed. Okay, so it's very non-specific, right? So the word changed here means different. Okay, and then that translates to not equal to. So when we set up the null and alternative hypotheses, okay, we're going to use the not equal to symbol in the alternative hypothesis. Okay, so the next part is asking us to identify the critical values and the rejection regions of our test. Okay, so we're going to do this in StatCrunch. Okay, so remember, to find the critical values, right, we need to know the level of significance, which is 0.10. Okay, the degrees of freedom. So we have 10 pairs of data. So we have the pass completion rates for 10 randomly selected quarterbacks, right, when they were freshmen and then when they were sophomores. Okay, and these values are for the same quarterback, okay, making this data set paired. Okay, so there are 10 data values. So therefore, the degrees of freedom would be 10 minus 1. All right, and then the other thing we need to know is whether the test is left-tailed, two-tailed, or right-tailed. Okay, so in this case, because the not equal to symbol is used in the alternative hypothesis, right, this makes this a two-tailed test. Okay, so we're going to go to StatCrunch and open up the t-distribution calculator. All right, because this is a two-tailed test, we're going to select between. Okay, and the degrees of freedom is 10 minus 1. Or you can go ahead and put 9 in there because 10 minus 1 is equal to 9. But I'm going to go ahead and leave it as 10 minus 1. All right, so in this box, we're going to put not the level of significance, but 1 minus the level of significance. So 1 minus 0.10. Okay. So for any two-tailed test, you're going to put 1 minus the level of significance in that box. And again, you can put that in your calculator to get the actual number. Okay, so 1 minus 0.10 is 0.90 or 0.9. Okay, so you can put 0.9 in there, but I'm going to go ahead and leave it as 1 minus 0.10. Okay, and StatCrunch will figure it out that that's equal to 0.90. Okay, and then the true critical values will appear in these boxes. Okay, so again, because the t-distribution is symmetric, okay, the critical values are the same value, but one's negative and the other's positive. Okay, so we're going to go ahead and round these to 2 decimal places. So in other words, for this two-tailed test, right, the rejection regions is in the left tail and in the right tail. Okay, so the critical values are negative 1.83 and the positive 1.83. Okay, so if the test were left-tailed, you would select option A. If it were right-tailed, you would select option B. Okay, but because it's two-tailed, we're going to select option C. So one of the rejection regions is less than the negative critical value, and then the other rejection region is greater than the positive critical value. Okay, so let's go ahead and check this. Okay, so it's correct. Okay, keep in mind that if you round it to a different number of decimal places than it asks you to, right, it'll likely mark your answer as incorrect. So even if you have the correct critical values, if you don't round them to the number of decimal places that it asks you to, okay, it'll mark it as incorrect. Okay, so make sure you round it to the appropriate number of decimal places. Okay, so in part C, it's asking us for the summary statistics for the differences of our data. Okay, so D bar, the mean of the differences, and then SD, the standard deviation of those differences. Okay, so let's go and copy the data in StatCrunch. Okay, so copy the clipboard. Okay, and notice that the titles are present in the data set, so that when I copy it in StatCrunch, okay, I'm going to find an empty column and then select the very top that contains the title and then paste the data. Okay, so the number of the player is in the left column. The pass completion rates when they were freshmen are here, and then the pass completion rates when they were sophomores are in the second column. Okay, that's how the table was set up. Okay, so what we're going to do is go to the Stat menu, select T-Stats, and then select Paired because the data is paired. Okay, so sample 1 would be the completion percent for the freshman level quarterbacks. And then sample 2 are the completion percent for the sophomore level quarterbacks. Okay, so these are both for the same quarterbacks. Okay, and we can save the differences in a separate column. And then you set up the null and alternative hypotheses correctly. Keep in mind that you cannot change the symbol here for the null hypothesis, but you want to select the appropriate symbol for the alternative hypothesis. Okay, and this difference is going to be assumed to be 0 unless stated otherwise. Okay, and we can also do a p-value plot, which is optional. Okay, so the mean of the differences, according to the output here, okay, so it tells you how the differences are calculated. So completion percentage for freshman minus completion percentage for sophomore. Okay, that's the difference that's calculated for each quarterback. So the mean of those differences is negative 1.67. Okay, it does say round it to 3 decimal places. So let's see if it'll accept the answer as negative 1.67. Okay, that's all the decimal places that they give us. So let's see if it accepts it. Okay, it does. All right, and then next we need the standard deviation of those differences. Okay, and unfortunately the output provides the standard error, but not the standard deviation. Okay, so you'll notice that the differences appear in a separate column, okay, next to the data that we just pasted from the table in the problem. Okay, so this is the data that we pasted from the table. Okay, and these are the differences, right? So freshman completion percentage minus sophomore completion percentage. Okay, so for some of the players, right, the differences are positive. Okay, that indicates that their completion percentages went down from freshman to sophomore. Okay, so here we have a positive difference for 4 for player number 2, or quarterback number 2. Okay, so the freshman completion percentage was 62.4. Sophomore completion percentage went down to 58.4. Okay, likewise, some of these differences are negative, indicating that their past completion percentages went up. So, for example, for player number 6, who had a negative difference, right, his past completion rate went up from 50 to 57.8. Okay, so in any case, right, so you get the standard deviation of those differences. We need to go to the Stat menu, select Summary Stats, select Columns. Okay, and then select the column that contains these differences. So it should be that last column on the list here. Okay, and you can select the mean and standard deviation, although we already have the mean. Okay, so in this box you have the mean, which you already have, and then the standard deviation, so 3.778. Okay, so I'm assuming that it wants it also to 2 decimal places, so it would be 3.78. Okay, it does want it to 3. Okay. So 3 decimal places, so 3.7789, so that's 3.779. We're rounded to 3 decimal places, so 3.779. Okay, now it's asking for the test statistic. Okay, so we want to go back to our results. Okay, so it's the paired t hypothesis test for the completion percentage. So let's open those back up. And our t-stat is negative here, so negative 1.397. Okay, so if it's to 3 decimal places, that would be the answer. Okay. So it does change here, which is a little confusing. So negative 1.39, so that 39 would get rounded up to a 40, so negative 1.40. Okay, would be that test statistic. Okay, and then lastly, we're going to decide whether to reject or fail to reject the null hypothesis. Okay, if it's difficult to tell by looking at the test statistic and then our critical values, right, whether to reject or fail to reject the null hypothesis, again, I created this diagram. So you should be in the habit of creating a diagram like this one, right, where you show the critical values, which are the cutoffs for the rejection region. Okay, you shade the rejection region, so you know which part of the diagram represents the rejection region. Okay, and then compare your test statistic to these two values. Okay, so if the test statistic is between the two values, right, in the unshaded region of the graph, right, it's not in the rejection region. Okay, but if it's in either one of the tails, right, either less than negative 1.83 or greater than positive 1.83, right, then your test statistic would be in the rejection region. Okay, so we can clearly see that the test statistic of negative 1.40, right, is between the two values, right, so it's in the unshaded region of our diagram. Okay, so what that means is that we do not reject the null hypothesis. So since the test statistic, okay, is not in the rejection region, okay, we do not reject the null hypothesis. Okay, we're going to select that as our answer choice. Okay, so we do not, or fail to reject the null hypothesis. So remember, the claim is represented by the alternative hypothesis. Okay, so because we do not reject the null hypothesis, right, it means we don't have enough evidence to support the alternative hypothesis. Okay, so in other words, there is not enough evidence to support the claim that the past completion percentages have changed. Okay, so statistically speaking, even though these numbers are different, the numbers are not different enough, statistically speaking, to indicate that there's a significant enough change in the pass completion rates for quarterbacks between their freshman years and their sophomore years. So let's go and check that answer. Okay, and we've correctly completed question 5. Thank you for watching.